Hello everyone, welcome to another episode for Learning Electronics. In this video, I'm gonna talk about diodes in circuit and what kind of rules we have to observe about diodes in designing circuits. So let's get started. So first of all, I want to talk about diodes in a nutshell. And what is diode? A diode is an electronic component that allows electrical current to flow in only one direction and prevents current from flowing in the reverse direction. In other words, a diode functions as a one-way switch. Diodes are made up to different types of semiconductors, p-type and n-type, that are joined at the point known as the p-n junction. And now, what is main characters of a diode? First, reverse breakdown voltage. The voltage at which the diode begins to connect reverse currents, potentially leading to damage. Second, forward bias voltage. The voltage that must be applied for the diode to conduct in the forward direction. Third one, reverse leakage current. The small amount of current that flows through the diode in reverse bias. Next one, forward current, the maximum current that can pass through the diode in forward bias without causing damage. We have types of diodes that I introduced them in a nutshell. Rectifier diode, used to convert AC to DC. Zener diode, operates in reverse bias and is used for voltage regulation. LED, or light emitting diode, using for light emission. Schottky diode has lower forward bias voltage and faster switching times. Photodiode conducts current when exposed to light. Important consideration when designing circuits with diodes. When using diodes in circuit design, several key factors must be considered to ensure proper operation and to prevent damage to the diode or other components. Now some tips. Choosing the right type of diode. Depending on the application, select the appropriate type of diode, rectifier diode, Zener diode, LED, or etc. For example, if you need to rectify AC current, a rectifier diode is suitable. If you need voltage stabilization, a Zener diode would be a better choice. Maximum current. Diodes have a maximum current rating specified in their datasheets. Ensure that the current passing through the diode in the current does not exceed this limit. Maximum reverse voltage. Diodes have a maximum reverse voltage, known as the breakdown voltage. The input voltage applied to diode in reverse should not exceed this value, as it could damage the diode. Forward bias voltage. To activate the diode and allow forward current flow, a forward bias voltage is required. Typically, for silicon diodes, the voltage is around 0.7 volts, and for germanium diodes, it is around 0.3 volt. Power dissipation. Consider the power dissipation caused by the current flowing through the diode. Each diode dissipates some energy in the form of heat. Ensure that the chosen diode can handle the heat generated. Diode placement in the circuit. Place the diode correctly in terms of polarity in the circuit. Incorrect placement can cause the current to malfunction. Circuit protection from reverse voltage. If there's a risk of the current being exposed to reverse voltage, use protective diodes to prevent damage. For instance, use a Schottky diode or a Zener diode for protection. Switching speed considerations. In circuit operating at high frequencies, the switching speed of diode is important. Schottky diodes are typically suitable for such application due to their fast switching times. Zener diodes for voltage regulation. If using Zener diodes for voltage regulation, ensure the diode is operating in reverse bias and that an appropriate current limiting resistor is selected to prevent excessive current from damaging the diode. Now we come to this conclusion that diodes are essential components in electronic circuit design used for rectification, voltage regulation, and other applications. Using the right diode and considering the above factors will help ensure optimal circuit performance and prevent failure. Now, what happens when multiple diodes are used together, and what are the rules and guidelines? Using multiple diodes in a circuit can have different effects depending on how they are connected and intended application. Diodes can be combined in various ways, such as series connection, parallel connection, bridge rectifiers, and more. Each of these configurations has its specific uses and characteristics. Now, explain them more. Series connection of diodes. In a series connection, multiple diodes are connected end-to-end in a chain. Features and applications. Increased breakdown voltage. When diodes are connected in series, the total breakdown voltage increases. The total breakdown voltage is equal to the sum of the breakdown voltage of the individual diodes. This method is commonly used when higher voltage tolerance is needed. Increased forward voltage drop. The forward bias voltage, the voltage required to connect current, is also the sum of the forward voltage drops of each diode. For example, if two silicon diodes with a forward voltage drop of 0.7 volt are connected in series, the total forward bias voltage will be 1.4 volt, same current. In series connection, the same current flows through all diodes. Therefore, if one diode gets damaged due to excessive current, the entire chain will stop conducting. Applications. Circuits require higher breakdown voltage and current limiting or circuit protection. Parallel connection of diodes. In a parallel connection, multiple diodes are connected simultaneously with both ends of the diodes connected to the same points. Features and applications. Increased current handling capacity. In this configuration, the total current is split among the diodes and different amounts of current flow through each diode, depending on their internal resistance. This method is used when higher current handling is required. Constant breakdown voltage. The total breakdown voltage of system remains equal to the breakdown voltage of each individual diode. Imbalanced current distribution. One issue with this setup is the uneven distribution of current. Diodes usually don't have perfectly identical characteristics, and small differences can cause one diode to carry more current, which may lead to damage. To solve this problem, balancing resistors are used. Applications. Circuits that require increased current capacity, power supply needed current distribution. The third one, bridge rectifier circuit. A bridge rectifier is a specific circuit commonly used for full wave rectification. This circuit consists of 4 diodes arranged in a specific way to convert alternating current to direct current. Features and applications. Full wave rectification. This circuit converts AC to DC so that both the positive and negative half cycles of the AC signal are turned into a positive DC output. Reduce ripple. The DC output from a bridge rectifier has less fluctuation, requiring fewer filters. Applications. Used in AC to DC power supplies, power circuits, and industrial circuits. 4. Combining Zener diode with other diodes. Zener diodes are often used alongside other diodes in protection circuits. These diodes are designed to operate in reverse bias and regulate or limit voltage. features and applications. Voltage regulation. By combining Zener diode with rectifier diodes, you can maintain a constant output voltage at a specified level. Protection from overvoltage. Zener diodes are often used to protect circuits from excessive voltage. Rules and key points when using multiple diodes. And now we want to talk about rules and key points when using multiple diodes. Proper diode selection. The diodes being combined should be compatible in terms of forward bias voltage, current rating, and breakdown voltage. Use of balancing resistor in parallel connections. Balancing resistors are commonly used to ensure even current distribution among diodes in parallel connections. Diodes must handle the required current and voltage. In any diode combination, ensure the diodes can handle the required current and voltage. Attention to total voltage drop in series connections. In series connections, the total forward voltage drop increases, which may require a higher voltage to drive the current. Heat management. In circuits where a large amount of current passes through the diodes, heat generation is a concern, and using cooling systems or heat sink is important. Conclusion. Now we come to this conclusion that using multiple diodes in various combinations allows you to modify current and voltage characteristics as needed, enabling the design of circuit for different applications. Depending on the circuit's needs and a specific use, you can connect diodes in series, parallel, or more complex configuration like bridge rectifiers. Proper diode selection and attention to design details can help ensure optimal circuit performance and avoid damage. All of the things that I mentioned them in this video that related to rules about diodes and when we wanna use them in designing circuit. If you have any ideas or comments about the other rules that we have to observe, please leave a comment. That would be awesome. Thank you for watching this video, and please give me a thumbs up. That helps us to continue making videos. For the next time, please take care, see you soon, and bye bye.